into the zeros for this.
You factor out x first.
Okay, and we're factoring out because we're trying to solve what? Huh?
How can equal to 0? So.
Yeah, we're trying to solve for when our function will equal 0. Okay, so you're right. We're going to factor out an x first. And then after that, do what?
X plus 6, x minus 1.
Okay. We need to factor this trinomial, right? So we still have the x here. We need a positive 5 in the middle, but we need the factors to give us a minus 6 at the end. So we're going to use a positive 6 and a minus 1. And then we now have our zeros. X would equal 0, negative 6, and 1. Alright, 0, negative 6, and 1. Now, just with this, guys, I can actually come up with a pretty decent sketch of what this function would look like. Okay? So, if I were to try to sketch this, the first thing that I would do is I would plot my zeros on the x-axis, because remember, zeros translate into x-intercepts. So I have one at 0, I have one at negative 6, and I have one at positive 1. Okay? Now let's think about what we did yesterday. What's our end behavior? What are we going to be doing on the right-hand side of this? It's going up because A is positive. We have a positive 1 in front of that x cubed, so I know this is going to be going up. What's going to happen on the left side? Is it going to go up too?
No.
Why is it going down? We've got an odd degree, okay? So this is going to do the opposite. All right, remember odd is kind of different. Okay, so if it's odd, they're doing different things on each end. So then you just need to fill in the middle. It's going to go through here, come back up through here, and then go down through there. Okay? And that's going to be the same every time as long as these are each single roots. Okay? Now, one comment I will make, if this factoring is still a challenge for you at this point, we need to do some extra practice, okay? Factoring is going to play a big part moving forward, okay? Not just in this unit, but in later units as well. You've got to be able to factor. You want some help, or you want some resources, I can help you find those, okay? But that would be, but let me know, okay? Now we have this one. Okay. This does not have a common factor. So how would we go about factoring it? We're trying to factor it at least. Page?
Grouping?
Yeah, grouping. Grouping. We're going to take grouping, we're going to take these first two terms, and we're going to look for a common factor just in those two terms. How many of you have heard of the term factoring by grouping? Okay, I know if you were here you have, but okay. So we, again, are setting this equal to 0, but we need to factor this by grouping, so we take
3x.
Good. A 3x squared out of those first two terms, and we get an x and a minus 4 left over. Okay? Then we're going to do the same thing with these two terms. Okay? They have a common factor of 4, and let's look at what I would have if I pulled it out. If I pull out a 4, I have a minus x, and I have a plus 4.
They go negative 4.
Exactly. Remember, the whole point of this method, as you've done this in the past, the whole point is we want these two parentheses to be the same. Okay? So, in order to force them to be the same, we wanted the x to be positive, and we want the 4 to be negative, so we're going to have to take out a minus 4. Okay? Does everyone follow what we did and why we did that? Okay? Alright, so now, if I asked you to factor out, let's say 3x squared y minus 4y, every one of you could do that, no problem, right? You'd pull the y out, and you'd get, in parentheses, 3x squared minus 4. Well, what we have here is essentially the same thing, except instead of a y, we happen to have a binomial. We have that x minus 4. So I'm going to take that x minus 4 out. And what's left over? Well, if I take it away from this, I've got a 3x squared. And if I take it away from this second half, I have 4.
It wouldn't be x minus 4 squared.
No, because you're taking out a common factor.
Okay.
Okay? And if you're not sure, you can always try to multiply it back in. Would you get the same thing if you multiplied it back in? So. Alright, so now at this point, all we have to do is identify our zeros. That's completely factored. So we know that one of our zeros is 4. We're going to have to figure this one out. And if you need to, go ahead and write it out along the side. 3x squared minus 4 equals 0. So you'll add 4 and divide by 3. X squared is 4/3. And then you'll square root. X is plus or minus the square root of 4/3. Okay? Now, here's one nice thing. Because we are graphing, you can give those as a decimal. Alright? Rather than rationalizing the square root, you can go ahead and give it as a decimal. I mean, that would be plus or minus 2√3/3. But since we're going to graph it, it would be helpful to have it as a decimal instead. Alright? So, as a decimal, that would be plus or minus 1 point what? What's the square root of 4/3? 1.78?
Yep.
Okay. You guys agree with that? Anyone else get that?
We got like 1.15.
You got 1.15?
Yes.
Come on guys, you all have calculators. Okay. 1.15? Okay. Okay. Listen, every one of you needs to learn how to use that thing, okay? Use that calculator. So you need to be practicing. When we do stuff in class, you need to practice using that tool so that when you get to test time, you don't even have to think about, oh, how do I do that on my calculator? Alright? Now's the time to learn all that. Okay, so at this point, we can actually get a pretty decent sketch of this. Okay, we have 1, 2, 3, 4, 1, 2, 3, 4. If I were to graph my zeros, there's 4. Here's a positive 1.15. Here's a negative 1.15. By the way, just by looking at the function, what other point do I know?
16.
What? What point is that? 0, 16, our y-intercept. Okay? So I know 0, 16.
Wait, how do you know 0, 16?
The constant term will always be your y-intercept. Okay? That'll help you in graphing these. Also, I can determine my end behavior. On the right-hand side, I'm going up because 3 is positive. On the left-hand side, I'm going down because I've got an odd degree, and I do the opposite. Whoa. That's weird. Okay? So now, I'm going to go through this. I don't know if that's a max or not, but I know I go through the y-intercept there. And then we come down through the other 0 and then back up. Alright, so a little bit of basic sketching, and notice we've got a good idea now of what that looks like. So, what do we do if our zeros have a multiplicity? Okay? What do we do? Multiplicity is when the same 0 occurs more than once. Alright? Here, if we were solving where x squared equals 0, we get x equals 0, but that has a multiplicity of 2 because it's both of the roots, 0 and 0. Here we have an odd multiplicity. X is 0 all 3 times. Okay? Our fundamental theorem of algebra says that we have to have 3 roots to this equation. They just all happen to be the same thing. Okay. And you'll notice in this case we happen to go through 3. Here we come down and touch at 0, but it goes back up. Alright, so notice the difference. Here when I had single roots, I went straight through the point. When I have a double root or a multiplicity of 2, I come down and touch the point and then go back. When I have an odd multiplicity, notice again I go through the point, but because it's a multiplicity of 3, it kind of levels off a little bit and then goes through the point. Okay? Yes?
Could it sort of be considered like the 2 points are like invisibly doing a curve?
Kinda, you could think of it that way. Alright? But here's the idea. Stick with me for just a sec. Alright? Here we have 0 that has a multiplicity of 2, right?
Yeah.
And we have 2 that has a multiplicity of 1 and negative 3 that has a multiplicity of 3. So notice it levels off but goes through negative 3. Then it just comes up and touches 0, but it goes straight through 2. Okay? So that's another thing to factor into our sketches. Alright? Alright, we'll let you go. Have a great day, guys.